Okay, this is section 3.1 for geometry. This first section has to do with lines and angles. Parallel lines, guys, you probably know what those are already, but the key word in this definition is coplanar. Okay, the two lines, if they're parallel, have to be on the same plane. They have to be for them to be parallel. So they're two coplanar lines that never intersect. Okay, they run right next to each other, they never cross. Now, as you can see down here, the symbol for parallel lines is like a really tall 11. Okay, it's just sort of like a miniature version of parallel lines. Now, skew lines, huge difference here. Skew lines are two non-coplanar lines that never intersect. Okay, so these are lines that are not in the same plane but never intersect. For example, if I chose this line right here, okay, and then let's just say I chose this line over here, okay, now this blue line and the yellow line are not in the same plane, but they never intersect. I mean, this line goes straight up and down over here, okay, and this blue line goes on and on that way. Now, you might say, well, this yellow and blue are going to intersect. No, it's just the angle that the box is drawn in, okay? They have to be in different planes for them to be skew. There is no symbol for skew, so you don't have to worry about that. Parallel planes are exactly as the name indicates. You have two planes that never intersect. So, for example, if you had this front plane here, and then you had this back plane here, the front and the back, those would be an example of parallel planes. Okay, the sides would also be, the two side rectangles would be parallel. The top and the bottom would also be parallel. Okay, so what we have here is we have three lines. We have line L, N, and M. Okay, and this line L has a special name. It's called a transversal. Okay, a transversal, and I'm sorry for my sloppy handwriting, a transversal is a line that intersects two or more lines. Okay, as you can see, L intersects N and M. Okay, so that makes L a transversal. Now, if we look at the whole area, oh, that's my washer, by the way, if you can hear that. Okay, it's singing us a nice song. So, if we look at this yellow area in between the two lines, we call that the interior of the lines. Okay? If I were to look at all of this outside the two lines, below and above, okay? It's kind of cool, I can color on here, as long as I stay inside the lines. Okay? That is the exterior. Okay? Now that's very important to remember. Hopefully it seems fairly obvious. It makes sense, common sense, that that would be the case. In between the two lines is interior, outside the two lines is exterior. The reason why that's important is because we're going to talk about 6 different pairs of angles. Now in your notes, they only mention 4, but I want to bring in the other 2 pairs of angles we talked about last chapter. Okay? The first pair is a linear pair. We know that. Okay? The linear pair, straight angle right here, that's 180 degrees. Here's 2 angles on the same line. If you add those 2 angles together, you get 180. Vertical angles we talked about. They make the X. We're looking at the angles across from each other. Okay? So we're looking, I'm having fun with colors, sorry. The angles across from each other. So 1 and 2 would be vertical angles. 3 and 4 would be vertical angles. So those are the 2 from chapter 1. Here are the new ones. Alternate interior angles. Now, alternate really means opposite. Okay? And when I say opposite, I mean opposite sides of the transversal. Now, if these are alternate interior angles, that means that our focus has to be between the two lines. Okay? Well, angle 2 is on the left side of the transversal, and angle 3 is on the right side. Okay? So 2 and 3 would be considered alternate interior. Now you might say, well, what about linear pair? Well, linear pair, the 2 angles would be next to each other. Okay? In this case, angle 2 and angle 3, angle 2 is at the top here, angle 3 is at the bottom. 4 and 5 would also be considered a pair of alternate interior angles. Okay, so there's two pairs of those. Alternate exterior. Well, now we're looking at the outside of the two lines. Okay, so again, alternate meaning opposite sides of the transversal. Angle 7 and angle 9 would be an example of alternate exterior angles. And then 6 and 8 would also follow suit. So there are two pairs of those. Corresponding. Okay, now corresponding, all right, there are 4 pairs of those. Now I want you to take a look. Take a look at those 4 angles there. And then take a look at, whoop, I just colored over them. It's all right, we can get it back. Here's 5, 6, 7, 8. Okay? Take a look at the positions. So like take a look here at angle 1. So that seems to be in the top left corner of this group of 4 in yellow. Now look down here at the 4 in blue. Which of those 4 angles is in the same or corresponding position with 1? Well, the answer is 5. Notice how 1 and 5 are in the same positions in their group of angles. So angle 1 and angle 5 would be corresponding. Now it would also follow then that angle 2 and angle 6 are corresponding. Angle 3 and angle 7 are corresponding. And angle 4 and angle 8 are corresponding. Okay? So there's 4 pairs of those. Now the other thing you want to notice here is that with corresponding angles, one angle is interior, one angle is exterior. Okay? Whereas alternate interior, they're both interior, alternate exterior, they're both exterior. Corresponding is one of each. Last one. You'll see it in the book you'll see it in the book as consecutive interior. Consecutive means 2 in a row. I always like to use the word same side because that's a lot easier for people to understand. Same side interior. Interior, obviously, we're talking about in between the two lines. So we're talking about this area in here. Now, same side implies that they're on the same side of the transversal. So if you look at angle 5 and angle 7, angle 5 and angle 7 would be same side interior. They're both inside the two lines, and they're both on the same side of the transversal. Well, there's a second pair, 6 and 8, would also fit that description. Okay? So those are that is the introduction to the angle pairs. There are 6, 2 from last chapter, 4 new ones for this chapter. Let me do a quick example of parallel and skew just to go back a little bit. I don't have the slides with me, or else I'd show you the slides that you have. Okay, but you could very easily work those out. So we'll label this A, B, C, D, E, F, G, and then H is this point down here in the back. So they want us to name all the lines. What if I wanted to know all the lines that were parallel to AB? Okay. Well, DC would be one, because that's the same plane that's in the front. ED would be one. I know that looks like a straight line. That's bad. I should change that. There we go. Okay. ED would be one. Now, you could make the argument that that FG would be one, because technically there is a plane going diagonal here. Okay. So you could make the argument that FG would also be parallel to AB because they are in the same plane, even though it's not drawn. So ED, DC, I'm sorry, that was EH. Whoops. Sorry about that. Let's erase that. And then FG. Okay. Now, if they asked for all the lines that are skew with AB, you'd have a bunch. Okay? We won't write them all out, but again, you're looking for if we're looking for skew to AB, we're talking about all the lines that are in different planes that don't intersect with AB. Okay? We'll go over a few of the examples tomorrow. Like I said, I don't have the slides, but this is the basic overview of the section. You should be able to finish the notes as you have them. We'll talk for a little bit tomorrow, and then you guys will have the whole period to work on the homework problems. Okay? So we will see you guys tomorrow. Make sure you watch this and take your notes because I am checking them. Bye, guys.